Good afternoon to Professor Ivan and my fellow classmates. And today I would like to share my estimation, the way I estimate the result based on the homework given. So examine the result, new cases, new tests, frequency index in Japan. So first of all, we took the variables first, the data. We take all the variables. Okay, then we copy the data and open eViews, choose daily 7 day a week. The end date is to January. Okay, we have 1077 observation. So let's click quit and then click empty group. Then we paste the data. So first of all, I examine the unit roof test first by using ADF. Let's say I took new cases and then I click view and then I go to unit roof test, standard unit roof test, and then just click OK. This is the result it has. So based on the result, the T statistic they get is rejecting the null hypothesis. So in this case, the variable is stationary. And we have go and I have go other test equation also. And the results shows that all of the variables here are stationary. As you can see that all of the calculation are rejecting the null hypothesis. So there is stationary in label and first difference. And so we can see that the stationary data here, we suggest to do the co-integration estimation through ordinary square to avoid misspecification estimation or something wrong. So how do we do that? I just go through with, let's say new text is the dependent variables. So I just open as an equation. Just click OK. And then we click plot, make a residual series. Just click OK. And then we go through with this view, and then unit roof test, standard unit roof test. Just click OK. Don't change anything. So the results shows that the T statistic it get is rejecting the null hypothesis as well. So it means that the variable new that is co-integrating with frequency index and new cases. So we can go for other estimation. Let's say new cases is the dependent variables. Then the rest is independent variables. So just repeat the same way. Just repeat it. Make a residual series. Just click OK. And then we click view, click unit roof test, standard unit roof test. Just click OK. And then the results, when the new cases is independent variables, the results also shows that there is a rejection of null hypothesis. So this means that new cases actually is co-integrating with stringency index and new text, new text. So when stringency index is dependent variables, okay, then we make a residual series, direct go through unit root test, standard unit root test. Let's just click OK. Unfortunately, the result shows that unrejected. There's no rejection of null hypothesis. So this means that the variables stringency index in Japan is not co-integrating with new dates and new cases. We have another co-integration test as well. For example, the co-integration test, the JJ, Johansen-Julius. So we take this one, just open as a group, and we click view, we click co-integration, Johansen system. So the length, about the length, just let EBE choose for us. So this is the results. The results shows that all of the variables are rejecting the null hypothesis. This means all of the variables are co-integrating with other variables. So these full rank cases circumstance encourage us to do granger causality in better auto correlation form bar, they call bar. So first of all, we click plot, make a better auto regression, and then we just click standard bar. About the length, we change to 4 to make it consistent. This is the auto regression, better auto regression estimates. So next step is we go view, leg structure, and we go for stranger causality. So in 5% of significant label, let's say lah, this one is rejecting the null hypothesis. This one as well. So this one, the null hypothesis is rejected. So it means that new deck cases, new decks, and new disk is causing to new cases. And then the another causal relationship will be new cases cause new disk. So the two variables, new case and new disk, are causing to each other. There is two-way causal relationship. So afterwards, we go view, and then we go for balance decomposition. We choose 50 years, 50 periods. Just click OK. Maybe they will be a little bit confused by looking at the table, but we can see the stack graph. So as you can see here, the new cases, the impact for new cases are smaller than the new ticks. As you can see, the new ticks in short of new cases, the impact for new ticks are consistently and continuously. It means consistent. Uh, and then if we're looking at the new cases, after the 10 years of short, uh, it has the impact from new cases. But we can see clearly about that the impact of from stringency index. As you can see, this graph and also this graph doesn't show the line of stringency index, the impact. So we can conclude that the new deaths is more likely exogenous, and the less exogenous will be stringency index. So when we go for the impulse response function test, we choose the general impulses, then we click OK. As you can see the result here, this is the impulse response function in bar. So as you can see, the impact from stringency index is stable, stationary, or less impact to other variables. Same goes to the other variables that impact to stringency index innovation. This one is so stable. This one also. Therefore, the stringency index is less exogenous, but the other impact from other variables are non-stationary if compared to the impact from stringency index. So that's all for me, for my estimation. Thank you for listening to my talk. Thank you.